Welcome to Let's Do It 518. Before we start this let's do another example of a linear transformation of a set of data and take a look at its mean and a standard deviation. In particular, we want to take a look at the standardized linear transformation of our age data. So let's get the calculator up here. And notice I've got my age data opened up over there in L7. Not really necessary to have that. It just kind of helps to see what we're doing, but you could do this without having it open in the editor. And I'm going to get on top of L6, and what I'm going to ask L6 to be is the age data. So I'll hit second list and then get number 7 where my age data is living. And I'm going to subtract from each one of the ages the mean of the ages, because remember, in the standardized linear transformation, or to create z-scores for all of my age numbers here, I'm going to take each of the ages and subtract from it the mean of the ages and then divide by the standard deviation of the ages. So let's go get the mean of the ages. So hit second and list, and then we'll go over to math and option number 3, and we'll go second and list, and then number 7 to get age. Okay, now if you're not staying up with me, no big deal. You can just sit back and enjoy the ride in the view, and that's just fine. Okay, or you can play this 3 or 4 times to see if you can actually stay with me. No problem either way. It's the punchline we're interested in. Okay, so we're going to divide by that. Second list, go over to math, go get standard deviation, go second list, go grab the age list, and now notice what is going to come in here are the z-scores for everybody's age in the class. Okay, so what this tells me is that the age of 16 was about 1 standard deviation below the mean. The linear transformation that we create using z-scores tells us the number of standard deviations a data value falls above or below the mean. It's in units of standard deviation. That's a very cool thing. Trust me, that's going to be a neat thing as we move through this class. So now notice as we get closer to the mean, the z-scores are getting closer to 0. Why is that? Because the number of standard deviations they are away from the mean is almost 0, right? Okay, so remember the mean was 26.5, so very few movements away from the mean for 26. And now notice as we start going up this end of the distribution, so we start getting up here towards people like me, notice that my age is 2.0423 standard deviations above the mean. This age is 2.6 standard deviations above the mean, and this age is 3 standard deviations above the mean. Okay, so that's how you interpret what the z-score is. Now, what our interest here at the moment is, though, is we want to go and take and calculate the mean and the standard deviation of L6 and show you that it doesn't matter what data set you use. When you do the linear transformation on it, the z-score transformation, you're going to get a mean of 0 and a standard deviation of 1. Now you're probably looking at me going, Mike, that means not 0. Well, it is. That's round off error. This is scientific notation in the calculator. This is negative 2.75 times 10 to the negative 14th, which means there are 13 zeros in front of that negative 2 there. So in other words, that's 0. It's just a little bit of round off error. The calculator couldn't hold the digits far enough to actually get a mean of 0 there. But for all practical purposes, in fact, in reality, that is 0. All right, let's go back to our LDI here. In LDI 518, what will he earn? So X is the number of products sold per week by a salesperson based upon the past 6 months with a mean of 18 and a standard deviation of 6. The 5-num sum was the min was 4, Q1 was 12, the median was 20, Q3 was 24, and max was equal to 37. Okay. Now suppose the salesperson earns $150 per week and $5 for each product sold. Give an expression that relates the weekly earnings to the number of products sold per week. Okay, so we want to find some way of calculating his earnings. Well, he gets $150 per week plus $5 for each product sold. So if we were to write that out into a linear function, then we know his earnings are going to be equal to $5 times X, right? Because that's each X represents the number of products he sold per week, plus his base salary, which is $150 per week if he just sits around and not do a dang thing. Okay, hopefully that makes sense. That's a little bit of algebra there. Okay, So what is the salesperson's mean weekly earnings? Well, he knows that he sells on average 18 items per week, right? So to find his mean weekly earnings, okay, all we've got to do, let's go ahead and do this one in pen. Let's get the pen here. To do that, we know that his X bar sub E, in other words, his mean earnings, is going to be equal to 5 times, well, let's see, what was his mean number of sales? Well, that was 18, so that's the X bar of the X's, right? Okay, plus 150. In other words, all we've got to do is just go ahead and plug those numbers into the linear transformation to get the new numbers. So let's go ahead and get our calculator out and do that. So we got what? 5 times 18 plus 150. So our poor salesman's only making about $240 a week. This guy is suffering, but that's okay. So we know that his mean earnings is going to be equal to, let's put the units down, it's $240 per week, okay? So how do we calculate the standard deviation of the earnings? Well, to get the standard deviation of the earnings, we'll do S sub E, and we know to do that calculation, all we've got to do is take 5, which is the slope, times the old standard deviation, which was 6, so that's going to get you back $30. So what that tells us is that weekly, we would expect that on average his data would be somewhere between 270 and 210 with respect to his weekly earnings, because that's the average distance away from the mean. Hopefully that made sense, that on a weekly basis we would expect his earnings to be somewhere between 240 plus 30, which is the 270, and 240 minus 30, which is the 210. Okay. All right, now they want us to go find the median weekly earnings. And they say the median is a measurement center transformed the same as the mean. And so that means his median earnings are going to be equal to what? Well, it's going to be 5 times, well, what was the median? Well, they told us up here the median was 20 plus 150. Okay. So let's go ahead and do that on our calculator. So that's 5 times 20 plus 150. It says about 250, okay? So his median earnings per week are about $250. What is the interquartile range for his weekly of earnings? And they say, note the interquartile range is a measurement of spread transformed like a standard deviation. So the IQR, or the interquartile range for his weekly earnings, is going to be equal to 5 times whatever the current interquartile range is. Well, to get our current interquartile range, we're going to take 24 minus 12, right? And again, what we're doing is we're transforming the number of products sold into money, okay? That's the transformation that we're doing, and it's done by a linear transformation, okay? I'm going to show you how you do the calculator to do that, okay? So I get the calculator up here, and so that's going to be 5 times parenthesis, I forgot the numbers already. It's going to be what? 24 minus 12. 12, right? There we go. And that gives us the new IQR is equal to 60, okay? So what that says is that the measurement of spread based upon the interquartile range is going to be $60. So what that tells us is that, if you want to think about that, is that tells us that we would expect, if you want to, I mean, although they didn't ask us to do this, we would expect about 50% of his sales are going to fall between 5 times 12 plus 150, that's Q1, right, which is going to be the lower end, up to 5 times 24 plus 150, okay? So that's the bonus round if you want to figure out what those two numbers are. And you can say that, you know, since this is Q1 and this is Q3, that 50% of the data have to reside between those 2 points, okay? Alrighty then, so that ends up our adventures in Chapter 5. A lot of good information here at the end of it. These last 2 LDIs are packed with information that's going to carry on into the next chapter. So we'll see you all back here for chapter 6.